So good everyone, you're welcome back to the channel. Today we're going to be looking at the topic curl of a vector. Curl of a vector, right? Now the curl of a vector, of a vector field measures the tendency of that vector field to circulate around a given point, right? And it's given by this formula curl of this vector f, the vector product this time around as cross product of delta and the vector itself. Now you know what delta represents, right? It's like the differential function or something that's tells us how we differentiate the vectors partially and sum everything up, right? Now I'm just going to throw a little light on what the curl actually mean or what it's talking about. Now from the definition, it says the curl of a vector field measures the tendency for that vector to circulate around a given point, to rotate, to spin around a given point, right? Now look at these points on, let's say, a vector field. I've located these points on a vector field. Now these points tends to make particles placed in it. Particles placed at these points to rotate, to spin, to turn around it. You understand? So these points here on wherever this vector field is tends to make particle rotate about this particular point, right? So there is actually a vector curl there, right? Now you remember this is our example from the previous video whereby I named this side, this point, this tap opening here, the source, right? And I named this part the sink, right, from the previous video. Now let's assume we have gotten some amount of water from our source and it's settled here, right? It's settled here. Now if you observe, if you notice sometimes when you open up the sink, right, to drain water from this sink, now you will notice that sometimes it don't just go in directly peacefully or linearly, right? There is this tendency for the liquid to curl, swirl, rotate, circulate around this point, this sink, this point, while going into the sink, right? There is this curl that happened before they all enter the sink, right? Now there's also, you can also visualize this curl in this case whereby we have, in this electric field aspect, whereby we have current flowing in this direction, and this vector field now tends to make this circle, tends to make this circular magnetic part around it, right? This vector current here, this vector field tends to create this swirling, curling, circulating magnetic field around it, right? And the direction of this curl can be noticed or seen, verified, or let's keep this way. All right, the direction of this curl can be determined using the right hand rule, right? Whereby you place your fingers against your palm and just stretch your thumb out. The direction of your fingers, which you have closed with your palm, shows you the direction of the curl, right? Direction of the curl. And then where your thumb is pointing out, that's the axis of rotation. All right. So let's take examples on the curl of a vector, right? So we're going to take first example, see how its calculation is different from the previous video. That's I think divergence of a vector, right? Now for divergence, we're dealing with dot products, and now we're dealing with cross products, right? Vector. So the resulting value here is going to be a vector quantity, not a scalar quantity, not just a value like 2, 3, 5, 6. It's going to be a vector quantity, right? So let's take the first example. All right, so the example we have here is find the curl of the vector field f equal to xy cube xz raised to power 5 and y raised to power 4z. All right, we're to find the curl of this vector. There is no specified point, right? So we're just going to calculate and just show or display how this vector tends to make particles spin or itself spin about. There is no specified point. All right, although the question can come with points or without points like in this case, but it's just the same procedure, right? So let's see what the solution is going to be like. Now we know the formula to use in finding the curl of this vector, right? We're finding the curl of f. We're going to have this delta or differential operator, this triangle that's looking upside down. Then we're going to have a cross product of that with the vector itself. Now how do we carry out this cross multiplication, this vector multiplication? this is what we do. This is what we do. We make use of matrices here, right? So if you have no idea how to work with matrices, you can just maybe check out our previous video. I think there should be a video on matrix on this channel. All right, so let's just go straight to the point. Now, this is going to look this way, right? I'm going to have ijk. This, you remember we talked about this, right? This is the I component, j component, and the k component. So I'm going to indicate or highlight the ijk, ij, and k, right? All right, so for the vector operator, the delta here, that's the partial differential with respect to x, partial differential with respect to y, and partial differential with respect to z, like we discussed in the previous video. All right, so I'm going to have the partial differential with respect to x here, then the partial differential with respect to y, partial differential with respect to z. You understand, right? That's for the delta or differential operator. Now, how about the vector itself? What's the I component of the vector? What's the j and what's the k component? All right, for the I component, we have xy cube, right? I hope that's clear. I hope that's clear. Okay, and then for the j component, we have xz raised to power 5, right? I hope that's clear. Finally, for the k component, we're going to have y raised to power 4 multiplying z, right? Okay, so now all we have to do is find the determinant of this matrix we just developed, right? This matrix that was formed, find the determinant of this matrix. Okay, so I'm going to assign signs to ij and k, right? This is going to be positive, this is going to be negative, and this is going to be positive, right? Just alternate the signs from positive to negative and positive, negative, positive, negative. You know how it goes for determinant of matrix, right? So I'm going to start with I component, which is actually positive, right? This is the positive I component, right? Then I'm going to cross multiply. Now you see this I component is located at row 1, column 1. The position of this I now is the intersection of row 1 and column 1. So if I'm to cover those rows, like, you know, exclude row 1 and column 1, I'm going to be left with these 4 terms here. So I'm going to cross multiply and find the difference between both of them, right? I is located at row 1, column 1. We're left with these 4 terms, 1, 2, 3, 4, right? Now I'm going to cross multiply. Cross products, right? Cross product. I'm going to cross multiply, right? Now this is going to multiply this, right? So the partial differential of with respect to y is multiplying this, y raised to power 4z. Is that clear? The partial differential of with respect to y is multiplying y raised to power 4z. Now I'm going to subtract that from the part. Okay, this is going to multiply now. Remember, it's cross this first, this direction first before this direction. All right, so the partial differential with respect to z, that's this, is going to be multiplying x z raised to power 5. Is it clear? All right, so let's proceed to the next component, that's g, negative g in this case. All right, let me not close my bracket yet so I don't get to squeeze in values the way I did for this case, because I want it to be clear and everybody should follow. All right, so this is negative j, right? J is located at row 1, column 2. Row 1, column 2. So I'm just going to struct row 1 and column 2. My lighting is poor and bad. Okay, so if I'm to exclude row 1 and column 2, I'll be left with these 4 terms. 1, 2, 3, 4. Right? Can you see those terms? 1, 2, 3, 4. So I'm still going to cross multiply those terms and find their difference as subtraction, right? So this is going to multiply this. This is going to multiply this, right? So what's this? This is the differential. It's not clear. This is the differential with respect to x. So the differential with respect to x is going to be multiplying y raised to power 4 z, right? Subtract this, we're cross multiplying. right? And the differential with respect to z is going to be multiplying this. That's xy cube, right? Then finally, we're going to have the k component, which is positive, right? K component happens to be positive. All right, and k is located at row 1, column 3, right? So if I obstruct or cover those two parts, you're going to be left with 1, 2, 3, 4, these 4 terms, right? We're still going to cross multiply as usual. You use this to multiply this, subtracted from this, multiplying this. No confusion, right? Okay, so let's multiply the change in, okay, the partial differential with respect to x with x z raised to power 5. So the partial differential with respect to x is going to be multiplying x z raised to power 5, right? Subtract, we're always minusing, right? Then the partial differential of y is going to be subtracting xy cube, all right? So we have the partial differential with respect to y multiplying this. Okay, so that's going to be x, y raised to power 3. Alright, I hope you're not confused at this point. If you have any question, of course, you can ask in the comment section and you get your answer. Alright, but I'm really hoping you're following. Alright, so let's see. This is I, right? We're going to simplify the terms in the bracket. Now, what's the partial differential of this term here? Y raised to power 4z with respect to y. How do you differentiate this partially, or just how do you differentiate this with respect to y? What do you get? Now we're going to get 4y raised to power 3z. I believe we are all familiar with what just happened, right? This is for the power of the term we're differentiating the variable. Now every other letter is going to be a constant, right? Since we differentiate with respect to y is the only variable there. C is just going to be a constant, right? So the power of y happens to be 4. You multiply that with your what's it called, constant, you get 4z, right? And then you reduce your power by 1. So 4 is going to be reduced by 1 and you get 3 here, right? That's how we got the power of 3. Alright, so there is a minus sign here. Then we have the partial differential this time with respect to z, right? So how do you differentiate x z raised to power 5? X z raised to power 5 with respect to z. Now we have z with a power of 5, so I'm going to multiply that power with the coefficient of z. That's 5x, right? 5x. And then the power of z is going to reduce by 1, becoming 4, right? Okay, so that's for the I part. This is I, right? Then we have negative the j part, right? Negative, then the j part. So what do we get? Partially differentiate this with respect to x, you get 0, right? Since there is no x in this term, there's no x in this term, you're going to get 0. And I'm just going to write to 0, okay? Minus, now you partially differentiate this with respect to z. There is no z there, so you also get 0 as well. That's just 0j component. Negative j, negative j, negative j, 0, just 0, right? Then we have the k components on the other side, right? So how do you differentiate this with respect to x? x 0 raised to power 5. How do you differentiate this with respect to x? You're going to get z raised to power 5, right? Hope there is no confusion there. You're going to get 0 raised to power 5. 0 raised to power 5. Okay, so there's a minus sign there, of course, and we're going to differentiate this final term with respect to y. So what do we get to differentiate this with respect to y? We're going to have 3x y squared, right? I believe there is no confusion at this point. Alright, so what's our final answer going to look like? I'm just going to arrange these terms and that will be the answer. Alright, so this is 4y raised to power 3. That's clear, right? Then we have z here minus 5x z raised to power 4. That's all for the I component, right? Then this is just going to be ignored since it's 0, right? Plus, okay, I'm just going to, oh, there's no need. Okay, it's k, okay, plus z raised by 5 minus 3xy raised by 2 k. That's the core of the vector. This is the core of f. It's a vector quantity, right? It's not a scalar stuff, it's a vector. Now if we are given a point, assuming we are given a point, let's say find the core of the vector at the point where x is 1, y is 2, z is 5, however they put it. All you have to do is substitute those values for x, y, and z. Alright, so you just get a number attached to I, a constant attached to k, and a constant attached to however your answer turns out to be. Alright, so if you're giving points, you just substitute those values and then get your actual I component, your actual k component. Alright, so let's take another example and hopefully that will be it for core of a vector. Alright, so now we have a second example to solve. Compute the core of the vector v. That's x minus y, that's the I component, plus x plus y, the j component, and z, just z for the k component. Alright, so what do we do? What do we know? What are we finding? Okay, I'm going to add at the point. Let's use our regular 1, 1, 2. Okay, you can use any point, but let's just use easy numbers so we just compute and be fast. Alright, so what do we know? We know that the formula for finding the curl of a vector is giving us curl of, this is v now, the curl of the vector v is the differential operator cross multiplying this vector product, now not dot product, the vector itself. Okay, so how do we go about this cross product or cross multiplication? This is what we're going to do. We apply matrices here. I hope this is clear. Alright, so we have ijk, right? I, and k. You can see how the vector was expressed in this question, different from how it was in the first question, but you are aware it's just the same thing but different format, right? So we have ij and k. What do we have here for the differential? We are going to have the partial differential with respect to x, the differential with respect to y, the differential with respect to z, right? Then how about the vector itself? For the I part, for the I component, we have x minus y, right? For the j component, we have x plus y, and for the k component, we just have z. Okay, so I'm going to assign signs: positive, negative, positive, just alternate the signs from positive and so on. Alright, so what's going to be? We're going to have positive, we're going to start with positive I, right? That's going to be positive I. Alright, and then this I is located at row 1, column 1, right? So excluding this row and this column, we're going to be left with just these 4 terms, right? We cross multiply them and we find the difference. Okay, so changing y, the differential of, okay, with respect to y is going to be multiplying z, right? So we're going to have the differential with respect to y multiplying z, right? Then we're going to subtract the differential with respect to z multiplying this, differential with respect to z multiplying x plus y, right? That's for the I component. Let's go over to the j, which is going to be negative. Negative j component is going to multiply what? What's going to multiply? Okay, row 1 column 2, right? Row 1 column 2 will be left with 1, 2, 3, 4. You cross multiply those 4 terms. Now the differential with respect to x is going to be multiplying z. Then we're going to subtract the differential with respect to z multiplying x minus y. Okay, then finally we have k, right? We have k, and k is located at row 1 column 3, right? Row 1, the last column. So we're going to be left with these 4 terms here: 1, 2, 3, 4, right? Now I'm going to multiply this with this, subtract it from this, multiply this. That's the cross multiplication there. Alright, so the differential with respect to x is going to be multiplying x plus y, right? And okay, we're going to subtract now. The differential with respect to y is going to be multiplying this, right? So we have the differential with respect to y multiplying x minus y, right? Alright, so let's differentiate and simplify everything. Alright, for the first part we have this. What's the differential of z with respect to y? That's going to be 0, right? Because there is no y here. This is a constant. We're differentiating with respect to y, so z automatically becomes a constant, and its differential is 0, right? Minus, what's the differential with respect to z of x plus y? Still 0, since there is no z here, there is no z here to differentiate, right? And that will be it for the I component. Now we move on to the negative j component. What do we have here? You differentiate z with respect to x. This guy is a constant since you differentiate with respect to x, right? You get 0. Now what do we have here? Another 0. That's for the j component. Alright, you differentiate x, y with respect to z. These are just constants. There is no z, there is no variable z there, right? It still results to 0. Alright, that leaves us with k. What's going to be another 0? No, it cannot be 0, bro. Alright, so you differentiate this with respect to x. What do you get? You get 1, right? Exactly, 1. Differentiate this with respect to 1. Alright, now we have this. Differentiate with respect to y, you get negative 1, right? X with respect to y, that's 0, but negative y with respect to y, that's negative 1. So I'm going to have negative 1 here, right? So at the end of the day, okay, this is for k now. This is for k. Alright, this is for k. This is going to be eliminated. We're going to be left with 1 minus minus 1. That's 2k, right? We didn't get the opportunity to make use of the points. That's to say that the curl of this vector at every point, not just this point, is going to be 2k, right? But if we were opportunity to make use of this point, like in the previous questions, you're going to just do, the substitution of those points and get something similar to this. That's a constant attached to k, a constant attached to I, a constant attached to j. Alright, that's how easy it is to find the curl of a vector. See you in the next video. Bye. Subscribe, of course.